Jochen Lillich, and he will talk about infrastructure as Ruby code. Please give him a warm round of applause.
Waiting for, yeah, the microphone is on. So welcome back from lunch. I hope you enjoyed it. All you need now is someone who talks very slow and softly. So I thought, since Ruby is most known for its web development capabilities, I'd introduce you to a little niche in Ruby programming, which is infrastructure as code, and in this case, it's Ruby code. In my talk, I'm going to first introduce you to the concept of IAC, then I'll go into the actual product that I've been using with my team for 14 years now. We'll go into a very small practical example, and we'll finish with questions. And before I get into things, a little bit about me. I'm Jochen. Lately, I've tried to get back into teaching and online education, something that I did in the early 2000s. At monospacementor.com, you can find my website where I'm going to offer courses, workshops, and where I'm also building a cozy little DevOps community. I also do regular live streams on Twitch, where I do basically my daily work, which is in part infrastructure stuff and in part related things. And you can also find me on Mastodon at floss.social/@monospacementor. Infrastructure as code gets interesting once you don't want to manually configure servers anymore. So if your number of servers keeps growing and you don't want to manually SSH into them and install packages, write configuration files, try to keep those configuration files somewhat coherent and in sync, then at one point, you'll probably have the idea, well, we need to centralize these things. We need to find a way to have central configuration. We need to be able to maybe version things so that we can see what has changed since last week and what's now broken, things like that. And that's where IAC comes in, which basically tries to move server management into the same position as we are with software engineering nowadays, where everything is under version control, where everyone has insight into the code that is actually in production and things like that. When I started my day job, a managed hosting company in 2010, I knew my number of servers would grow, so I was looking for solutions, and the solution I eventually decided to use was called Chef. Chef was started by a company named Opscode in the beginning, then later they renamed themselves into Chef Software. And if you think the recent debacles with open source licensing that we saw with Terraform and Redis were new, you are mistaken. In April 2019, Chef Software made a change to their licensing where they said, okay, we'll move all our software licenses to the Apache license, but distributions of that software need a commercial license if you use them in a commercial setting, which means you would either have to package Chef software yourself and become a software maintainer instead of a software user, or you would have to pay. And that, of course, led to the now quite common reaction by the open source community of forking the whole project and publishing it under a real open source license. And that's exactly what happened here as well. And so now there is an alternative distribution of Chef and all its components, or most of its components, called Sync, which is a recursive acronym which means sync is not chef. Sync covers the main components that make up the whole ecosystem of Chef. That's the central sync server, the sync client, the test framework called Test Kitchen. Then there's sync auditor and sync workstation, and I'll get into that. And by the way, the whole ecosystem around Chef uses kitchen metaphors. So for example, the tool that you use to interact with a Chef server is called Knife. And there's Test Kitchen, the test framework. There are many other kitchen metaphors. And you can't imagine how much of a nightmare searching on Google for these tools is. So this is how the basic architecture works. Chef, for example, different to something like Ansible, uses central components, mainly the the sync server. I'm going to use sync and Chef interchangeably here. The sync server uses a data store which consists of PostgreSQL and Redis, a search index that initially used Apache Solr and now uses Elasticsearch, and Bookshelf, which it uses to store the cookbooks. And client nodes, which basically is synonymous with servers, then interact with the sync server, and you execute the sync clients on these machines. They ask the sync server what they are supposed to do. The sync server tells them, and then you simply run the sync client on a regular basis, maybe once an hour or something like that. And the sync client makes sure that the server looks like you've described how it is supposed to look like. So in the ideal case, if the server already is configured as it's supposed to be, the sync client will run through everything, see that all is in order, and then quit again. And otherwise, it will take the necessary measures to get the server up to speed. You can also interact with the sync server as a user, of course, so that allows you to administrate the whole thing. I did mention cookbooks. Cookbooks is basically where your code lives. So cookbooks are a bunch of Ruby files that describe what is supposed to happen. And the main part of these cookbooks is the recipes, which are Ruby code describing the different resources that you want to configure. And there are a lot of resources. I'll get into that in a minute. Your cookbook can also provide a bunch of files that you've already prepared and that you want to deploy on your servers. But mostly, if we're talking about configuration files, there is, of course, some variability in there, and that's where Chef uses templates in the well-known ERB format. Chef already comes with a large list of resources that you can describe. Resources like packages that you'd like to install, files that you want to deploy, cron jobs that you want to define, things like that. And if Chef doesn't come with what you need, or you need to have something more sophisticated, then you can also add custom resources, also written in Ruby, to the whole mix. Something that I ignored for far too long was tests. I simply did not make the connection that something that is, by now at least, ubiquitous in software engineering also should be applied to infrastructure as code. Deploying changes to our cookbooks was often anxiety-inducing because running stuff on a production platform where you get paid thousands of euro per month from a single customer to keep their websites online, and then having a code roll out to hundreds of servers that might break something is yeah, that is costing your nerves, no doubt. And when, after a few years, we had decent test coverage, things changed significantly. And we now are pretty confident in rolling out changes, even on a Friday afternoon. And that's thanks to good test coverage in that regard. And I'll get into the details of testing in a few minutes as well. Now, cookbooks, even though you can, of course, deploy new versions of your cookbooks, are pretty static. And there is also data that you want to get into the mix. Some information might be node-specific, and by node I always mean server-specific. Not only do you want to run different cookbooks on different servers, for example, you might want to run a MySQL cookbook on a database server. You might want to run a Apache cookbook on a web server, things like that. But these servers might be different in how many web workers you want to configure, or how much memory you want your MySQL database to consume, and things like that. And that's where attributes come in. Each node in your whole system can have specific attributes that you set and that get used by the cookbooks. Of course, there are often very high similarities between servers, especially if we're talking about a cluster of web servers. You want to have them to have a consistent configuration, and that's where you can use roles, which also define these attributes, but then you simply go and say, okay, you are a web server, you are a web server too, and you are a web server too, and all of them get the same set of attributes and even the cookbooks that they execute, and we'll see that in a minute. There's also a way to have data that is node independent, and Chef calls them data bags, which are basically JSON files that you can then use from your cookbooks. They are stored on the Chef server as well, and you'll use them for stuff that's not server dependent and more abstract probably. For example, on our managed hosting platform, each website has its own data bag item, a JSON file that has the list of domains for that website, the PHP version it uses, and things like that. I already mentioned the built-in resources. Chef comes with everything that's common in system administration. Probably when you first spin up your Linux server, you want to start installing packages, and that's why there is a package resource. A file resource is a simple way to get a file on disk, for example, by simply writing some text into it. But the templates are more flexible because they are based on ERB, where Chef first replaces placeholder code or even executes Ruby code to then finally render this file and write it to disk, similar to how Rails renders its views as well. The service resource is to manage services, namely daemons that run on your machine. So you can say, okay, start MySQL after it's configured correctly, or restart MySQL after you've made changes to a configuration file. So you can also make resources dependent on each other. For example, you can tell Chef to write a MySQL configuration file using a template resource and say, if you have to change this file because for some reason the content of this file had to change, then notify the service resource for MySQL to do a reload of that configuration. If you want to do some low-level stuff, there's the execute resource that simply allows you to execute a command. And if you want to go really down to the metal, you can also execute Bash or Ruby code by using the eponymous resources as well. There is a cron resource, and for everything else, I'll refer you to the sync or Chef documentation, because there's a lot more stuff. Also, for example, resources that are specific for Windows hosts. And The nice thing about Chef is that it abstracts things in a way that you don't have to deal with the minute details. For example, you can use the package resource on any Linux distribution, and Chef will automatically decide what the package management system it is supposed to use. So if you say package Apache, on Ubuntu, it will use apt to install the Apache package, and on Fedora, it will use DNF to install it. You don't have to build nearly identical codes for different Linux distributions, things like that. Let's get into a simple example how this looks in practice. I've chosen a purpose that I can highly recommend, namely making backups. And we'll simply build a skeleton of a cookbook that uses Borgmatic to set up a backup service. So first time we run our Chef client, it probably should install everything that's necessary. So that's where the package resource comes in. I simply tell Chef to use the package resource on Borgmatic, and I wouldn't even have to tell it that I want the install action, because that's the default action anyway. So just having package Borgmatic without the block after it would work just the same. And speaking of block, when I started using Chef, I didn't even realize that I was using Ruby, because I just copied and pasted these things from the documentation. It all looked pretty understandable. Yeah, package, Borgmatic, and between do and end there are the details. That makes perfect sense. And only a few weeks or even months in, I realized why these files end with .rb. And, my love with Ruby began that day. So here's another resource then to deploy the configuration file that Borgmatic expects. And as you can see, it gets just added to the same file we had previously, which is Borgmatic, which is our cookbook, /recipes/ in my case, I just went the lazy route and chose default.rb as my file name. And here, the template resource uses a few more attributes than the package resource, because yeah, that task is a little bit more complex. The resulting file is supposed to have specific owners, groups, and a mode. I find it particularly convenient that I can write the mode in octal, because that's how things are stored on disk, actually. And I'm, as a system administrator, which I've been since 1993, I'm very familiar with these numbers. And so I'm always using the octal notation here. Of course, the first information is one of the most important ones. That's the source file for the template. And as you can see, it's an ERB template that then gets rendered as my config.yaml file. I can pass variables to this template, which simply get turned into instance variables that I can then use inside the template, just like you do with controllers and views in Rails. And there's something more here, because for the config variable, I pass in a value that comes from node, and then apparently it's a nested hash with the key Borgmatic on top, and then under that the key config. And that is a node attribute. Node attributes allow you to pass in as many parameters as you want. And for example, for our purpose here, we need a few configuration settings, mainly the source directories that you want to have backed up here. So in the node attributes, I can simply introduce a top-level key Borgmatic. I'm using these top-level keys like namespaces, and I think it's best practice to name those top-level keys after the cookbook name. That way it's easy to identify which attributes belong to which cookbook. And under that, I've simply introduced a config key, and which has configuration settings under it that I'm going to use in my configuration file. And I've just included here one example, which is the array of source directories, which I then can reference in my template file. I simply use the placeholder notation of ERB to reference the source directories key in my config variable, which is already, let's go back here, the hash under Borgmatic config, so that's not visible anymore. Then I simply build a list of my source directories that Borgmatic is supposed to back up. What if we want to introduce multiple configuration files? Because, for example, you might want to back up locally and to an external repository. Well, we'll just restructure our configuration document here. Instead of having a single config key, I'm introducing a key named configs, which under it has another hash with my different configurations. In this case, a key config1 and another one with config2. And both of them have their own configuration settings. And once you know that chef cookbooks are Ruby, you can use Ruby in your recipes. For example, here I simply iterate over my keys under configs, use the key with the name iterator and the value behind it as config. And then I'm basically using the same template block that I used before, but using name for the file name. And again, config as my config instance variable. And that way I can write an arbitrary number of configuration files. Finally, I'll simply have to set up a regular backup schedule using cron, using the cron resource that Chef provides me with. It'll be stored under the name Borgmatic. It'll execute the usual Borgmatic command referencing the configuration file that I created earlier. And here we have a few additional attributes, hour and minute for the timing, and the user this command is supposed to run under. And since I want to probably back up my /etc directory, I'm running this command as root. Since we are using node attributes, it's a good idea to actually provide default attributes, and I can do that from my cookbook directly by adding another file under the attributes directory, where I simply define default values for my different attributes that I'm using. That way I can actually run this cookbook without manually defining any node attributes. The cookbook comes with hopefully sensible default values already. Otherwise, if I want to change those values, I need to tell Chef, for this node, please use this value for the hour. And for this other node, please use this hour, so that all backups run at the same time, overwhelming my backup server, for example. This manual assignment of attributes is a little bit tedious, and that's why roles make things a little bit easier. I can create additional roles files, either in Ruby syntax, or here I've chosen JSON as my format, where I can define commonly used attribute values. For example, I want all backups to run at 2 o'clock. And I can also define the run list, which means all nodes that have this role in their run list, in their local run list, will automatically execute my Borgmatic cookbook, namely its default recipe. And that way I can change this central role. If I want to have a different timing, it'll apply to each and every node with this role next time I run the Chef client. Finally, as I emphasized earlier, we want to have some testing. Chef has a nice test framework called Test Kitchen, which either spins up virtual machines or Docker containers to first run Chef inside it. So it spins up some kind of Linux that you can define. Then it installs Chef, uploads your cookbook, executes your recipe, and then it runs a verify, the actual test, using a tool called inspec if you're using the commercial version of Chef, or Chef Auditor if you're using Sync. They had to change the name for copyright reasons. Both are inspired by server spec, which in turn is inspired by RSpec, so the syntax will be very familiar to most of you. The interesting thing is that Sync Auditor can not only test your cookbooks in development, you can actually run it on your live servers as well. So for example, if you have regulations where you need to audit your machines, where you need to make sure that not only your cookbooks are working well, but your infrastructure is exactly at that state that you want it to be in, then you can actually use Sync Auditor to verify your own production environment as well. And that's how it looks like. It's again a combination of describe blocks with examples in there, a little bit different from RSpec, but it's easy to read, I suppose. So I make sure that the package Bogmatic has been installed. Then I check that the configuration file not only exists, but also contains specific values that I can predefine. And finally, I check that the cron tab actually has an entry that needs to be there. Otherwise, maybe I'll deploy a perfectly working cookbook that whose backup command never gets executed, which is pretty bad for backup. And that way, I can also make sure that the cron job gets installed with the proper time. That, of course, was only a very simple example. You can, of course, get more complex. I don't know how many thousands of lines of Chef code we have in our code repository. After 14 years, we've accumulated quite a bit. And you can, of course, also use cookbooks from third-party developers. There is, of course, an open source community around this with cookbooks that you can reuse. And you can also apply a method called application cookbooks, where you basically build your cookbooks on the basis of other cookbooks. For example, we tend to build very low-level cookbooks for a specific service. For example, we have an Nginx cookbook that simply takes care of installing Nginx and setting up a decent configuration file. But then we have our own company-specific cookbook that uses the Nginx cookbook to set up things that are very specific to our company. And this separation, of course, allows us to open source the Nginx cookbook because it's very generic, but we keep our own company-specific stuff to ourselves because it's only of use to us anyway. And of course, you can go wild in creating your own custom resources. And that's thanks to Ruby, because I really like this, what's called an imperative approach, where I can tell my Chef client exactly what to do. I can use everything out of the arsenal that Ruby allows me to do. Just one example is, over time, our recipes grew and grew. We started doing API calls from our recipes and all kinds of stuff. And we ended up basically where we were with, say, PHP in the early 90s, HTML files with lots of code in them, completely unmaintainable. And just like that community then started separating things with HTML and templates and PHP code separately with object-oriented classes and everything, we've been doing the same, where we have libraries that are full of Ruby classes that do all the business logic. And then we have Chef recipes, where we simply call the usual Chef resources and instantiate the classes that we've defined elsewhere. So you can actually do proper software engineering with infrastructure as code too. And I hope you'll have fun exploring this. Any questions?
First of all, thank you for the talk. When I used Chef before the fork, there was the thing with knife zero and
Chef
knife,
zero.
and knife solo or solo. Is it still a thing that you can also have a lightweight infrastructure where you deploy without having the whole, a separate server that manages everything, or is this lightweight approach not common anymore?
I'd have to check on this. So what they're referring to is, as I said at the beginning, Chef is a very centralized approach. You have the client that needs to have a server that tells it what to do. So if you have only a few servers, you might actually not want to have a central server with its own database and all that stuff. For that, Chef came with what's called Chef Solo, which was able to basically be a Chef client that has all the cookbooks locally, can read them and execute them. Of course, there will be no central node attributes or centrally stored data bag items, things like that. But for smaller installations, that was enough. Chef Solo fell out of fashion, that's what I know. And since we never used it at all, I can't actually tell you if it's still around.
All right, thank you very much. On time, really. For further questions, I have to ask you to come then back to Jochen and ask him in the breaks or on the party tonight. Thanks a lot.
Today and tomorrow, so just hit me up.
Thank you, Jochen.
Thank you.
Applause.